Welcome back. This is the third episode of the first block of theory lessons. In this episode, we will talk about HAPs generated by dinoflagellates as well as their harmful effects. Dinoflagellates are a group of flagellate eukaryotes. Most of them are part of the marine plankton, but we can also find a few species in freshwater systems. Many of them are photosynthetic, that means that they use the sunlight to do the photosynthesis and produce oxygen. But some of them are also mixotrophic, that means that they can either do the photosynthesis or ingest prey. The bloom of certain dinoflagellates produces what we know as the red tides. I'm sure you have heard this name many times, a red tide. This is a visible coloration of the water that can be composed not only of dinoflagellates but also of diatoms or other types of phytoplankton. The term red tide is actually not very accurate because, as you have seen, for example, with the cyanobacteria blooms, not all the HAPs are red. Some of them are green, brown, blue, whatever, but not only this, they are not tides. So it is better to use the term HAP, harmful algae bloom, than to use red tide. However, we continue using it because it's a term that has been used for many, many years now. One example of a red tide generating dinoflagellate is Karenia brevis. We will talk a lot about Karenia brevis, which is this one that you can see here in these images. Karenia brevis typically generate blooms along the Florida coast, as you can see here in this remote sensing image. These colors, they indicate concentration of phytoplankton, in this case, mostly Karenia brevis. Karenia brevis harmful algae blooms are a seasonal event. Again, it's something that happens naturally every year and can they normally peak during the late summer or early autumn. Along the Florida coast, these events can last for up to 18 months, and that's when it becomes really bad. But the first report of the existence of these Karenia brevis red tides or HAPs, they were reported by the Spanish explorers in the 1500s. So this is suggesting that there is a natural occurrence of these organisms. However, there are many studies that suggest that HAPs of Karenia brevis are increasing in frequency and is probably related to climate change or to the increase in nutrient pollution due to farming and landscaping. As we can see here in this example, we have here sources, potential sources of nutrients into our water courses that can end up in lakes or in the estuaries and can lead to harmful algae blooms. We can have, for example, from animal manure, from farming, from houses, from industries, wastewater plants. We will see this in detail later, but these are all potential sources of nutrients into the different water bodies. NOAA monitors conditions on a daily basis in the Gulf of Mexico along the east coast of Florida. NOAA is the national organism for atmospheric research in the States and oceanic research. And they monitor on a daily basis because they do have these Karenia brevis blooms along the Gulf of Mexico and along the east coast of Florida. And we're going to see that Karenia brevis blooms can be really nasty. The good thing is that because they monitor on a daily basis, they issue 2 forecasts each week to inform about the existence or not of these Karenia brevis blooms and the potential for their impacts. But also, if you subscribe to the webpage, you can get a report on a daily basis, so even more frequent. So let's think, for example, that you want to go to the beach and you don't know whether you are going to find a fantastic day at the beach or you are going to find a nasty algae bloom. You can log in into their webpage, you can find the beach where you want to go, and you can see the report telling you whether it is safe or not to visit this place. So why do they have this huge monitoring program and forecasting program of Karenia brevis? Well, because their harmful effects can be really bad. These organisms produce very strong neurotoxins that can have several harmful effects. For example, They can affect the central nervous system of many animals, including fish, manatees, dolphins, sea turtles, birds, and it can actually kill them. Dead organisms, as we have already seen, are organic matter, and this is, as they die and as they sink, what they are actually doing is supplying nutrients to the blooms as they decompose. So we have a bloom of Karenia brevis. Zooplankton eats this toxic phytoplankton. Fish eats the toxic zooplankton. They die, they sink, bacteria decompose this organic matter, regenerate the nutrients, and let's say we have an upwelling, a coastal upwelling, that is bringing these nutrients back up to the surface, so we continue having warm water conditions and plenty of nutrients. So again, the bloom can continue, and that's why in the Florida coast they can last for up to 18 months or even more, because they can be even fed by their own bloom, by the consequences of their own bloom. A second effect of this strong neurotoxin is that if the red tide is found near the beach, the waves, when they break, can actually break the cells of this organism and release the toxin into the air. So this toxic air can cause respiratory irritations or even serious problems. If there is a person that is vulnerable, for example, a person with asthma or with another respiratory condition, if they just have a walk on the promenade in a place where the waves are breaking and we have a Karenia brevis blooms, if they inhale this toxin, they can get sick. But not only this, this toxin is very well known for killing manatees. Manatees are huge organisms. They are marine mammals. They are very large, and they can die not only by ingesting the water that it contains this toxin, but even from inhaling the water. So it's a very, very strong toxin. This toxin, of course, can also accumulate in filter feeders like mollusks, such as oysters, clams, mussels. So if we consume contaminated shellfish, we can develop a sickness that is called neurotoxic shellfish poisoning. This neurotoxic shellfish poisoning typically causes diarrhea and discomfort for a few days in humans, but it's not fatal. The effects are not as bad as in the animals. And of course, as we saw before with cyanobacteria, if we have a massive bloom, as the organisms die, they sink, bacteria use the oxygen to decompose all this organic matter, so they can deplete the dissolved oxygen in the water column and create a dead zone due to this decomposition process. So let's see some examples of Karenia brevis blooms in Florida. During a bloom that lasted from 1987 to 1988, so 1 year of a continuous bloom, more than 740 bottlenose dolphins died after eating contaminated fish. In 1999, 149 manatees died off the coast of Florida because there was a Karenia brevis bloom. In 2006, there was another bloom of Karenia brevis that lasted for more than a year and a half, and it killed more than 250 manatees. But the worst red tide to date, the worst hub of Karenia brevis in Florida, took place between October 2017 and most of 2018, and it killed thousands of fish, at least 60 turtles, manatees, even a whale shark. It was a massive bloom that lasted for a long time, and it had a huge concentration of toxins. Even hundreds of seabirds, they either got sick or they died. As you can see, these are actually real images from that bloom in 2017-2018. This poor thing here is a manatee. These are other images of that bloom between 2017-2018. You can see here dead fish along the coast, and you can see hundreds and hundreds of dead fish in this small harbor here. If we have a look at the maps showing the spatial distribution of this Karenia brevis toxin, I don't know if you can see this red dot here, we can see that in 1970, in the top panel, there were just very few locations that they had reported these Karenia brevis blooms. However, if we have a look at the bottom panel, which is for 2015, you can see that these toxins had spread everywhere. Even in Europe, we have many, many places where this toxin has been already reported. Other example of dinoflagellates that they can generate HAPs are, for example, Noctiluca scintillans is a dinoflagellate that is very commonly found in Australia and generates these beautifully colored red waters. And it's a natural occurring bloom, but they can be a hazard to swimmers because even though they are not very toxic, they contain high levels of ammonia, and this ammonia, simply because they are in very high concentrations, ammonia can cause skin irritations and rashes and irritations in our eyes and our nose. So it's not nice to swim if we have this kind of blooms. Other example of organisms, there are many. We have, for example, these three here, Serratium furca, Prorocentrum micans, Alexandrium catenella. These are typical in the Benguela upwelling system. And actually this Alexandrium catenella is not found along the full coast where the upwelling system is located. It is only found in certain regions of the upwelling. And other species. Other species, for example, of dinoflagellates can produce toxins that can cause paralytic shellfish poisoning, or diarrheic shellfish poisoning, Ciguatera fish poisoning. So there are many species of dinoflagellates that can produce toxins. If you want to learn which other algae generate HAPs and what their harmful effects are, please join me in the next episode